The derivative at a point. Derivative. F prime of x, which is the derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. You know that. This is a power rule. If you have some constant multiplied by x to the power, take the constant, keep it, multiply by n, multiply by x to the n minus 1 power. Now, that might seem a little convenient, but if you want to proof for it, just look up binomial theorem on Wikipedia. There are a lot of proofs of this, but that's probably the most popular. I think it's pretty cool, but blah blah blah. So, we have another one. F of x equal to g of h of x. Well, we know g is changing, but we also know x is changing, or h of x is changing. So, we want the instantaneous slope of g with respect to the instantaneous slope of h. So that's simply defined as the chain rule, h prime of x, g prime of x, f h of x. Products rule, g of x multiplied by h of x, f prime of x equals blah 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 blah. Quotient rule, the exact same thing as this, except it's 1 over h of x. So yeah, I don't feel like I need to explain the quotient rule because it's just the product rule. Okay, here we go. Standard definition of a derivative for sine of x is equal to f of x. Well, we know what is the derivative of sine of x, because f of x is the derivative of sine of x. F of x equals cosine of x, f prime of x equals negative sine of x. We want for a point, f prime of pi over 2 equals negative 1, because the sine of pi over 2 is 1, multiplied by the negative sign, blah 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 blah. A little more intriguing one, we say f of x is defined as the integral from 0 to 3x of x squared dx. Now this is actually the t squared dt, but that's arbitrary and it doesn't really matter. Plug in 3 of x multiplied by the derivative of 3x, which is 3. We know the derivative of the integral is simply the function. F prime of x equals 3x squared. F prime of 2 equals 12, because 4 times 3 is 12, as I'm sure you all know. You are very intelligent people. You can do basic multiplication. Now, we say the limit as x approaches c of f of x, of f of c is anything really. But we know that the derivative at point c only exists if this exists. And this exists only if f of c is the same as you approach from the right and as you approach from the left. So, are any of these points differentiable? Well, is the limit the same as you approach from the right as you approach from the left? For a. Well, yes it is. So, a is a differentiable. Or x equals a, you combine the derivative at that point. You cannot for b, because there's a corner. At a corner, what is the derivative? Is it 0? Is it this slope? Is it that slope? You can't really define it. So, it does not exist. Same for the rest of these. Corners, 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 corners. No bueno. Cannot have. Bad. That's it. I know it was really quick, but derivative at a point is not that complicated. I'm sure you are all completely proficient in taking the derivative at a point. Just take your x value, plug it into the derivative equation. Not that bad. So, that's all.